described it. I'm going to leave you with one last thought. I'm going to be kind of done for this. We're going to do some more things, but I do not know who wrote this quote. It was here when I got here, so I'm assigning it to anonymous. But this is one of the better quotes on visualization I've ever seen. And I think it puts it into a nutshell. And let me just read it if you can't see it in that. Even the experienced engineer or designer cannot look at a multi-view drawing and instantly visualize the object represented, except for something very simple, like a washer or a piece of paper. Any more than we can grasp the ideas of a book page merely at a glance. And that's so true. It is necessary to study the drawing, read the lines in a logical way, piece it all together, piece those little things, until a clear idea of the whole emerges. That's well aptly put. That's what it takes. Don't think you're going to look at a multi-view and be able to do it. Out of all the years I've taught, I've seen one person that was natural at this. One. Okay. Everybody else has to learn it. Okay. I think that aptly states. All right, now why else did I jump into this chapter? Let's go to the back of it. There is some awesome stuff here that I think you should take on. I'm not going to assign a grade other than 1, but I do have the grade sheets for all this stuff. Okay, so I'm in the back of chapter 5. So here they have 2 slightly different shapes, A and B, and then they show them in different configurations. Can you take these objects, tumble them in your mind, and identify which one you're looking at? Kind of a little brain teaser, but it's a good start on taking 3-dimensional objects and tumbling them in your mind. So I like that one. This one's even better. It's on page 169. If you want to sit down and do these, please do. I've got all the answer sheets. You can check your answers. I think the next one's the one that always gets me. Yes. Page 170. Okay. I try to do this once a year. I'm getting to where I'm getting close to 100%. P's and Q's. Can you visualize which one's which? Okay. Yeah. So those are great. Now, there's a couple following that. And I'm going to ask that you do this. You're really welcome. These don't take a huge amount of time, but they're a good start on working 3-dimensional to 2-dimensional. So let me just kind of explain what you're to do. So you are given a nice metric view. I would like this to be the front, that to be the right, that to be the top. Now, as you look at these 3 views, keep in mind they come from the glass box. They are orthographic views. This is going to be your front, right? This is your right view. Here's your top view. Okay. So what you're going to do is take the letter off of the isometric and find those planes over on the right. So let's take the first one, surface A. If I go to my front view, which one is surface A? Number 20. So that's on the front. Now, in the top view,
1.
okay, here you are seeing here you're seeing the face view of it, right? Here you're seeing the edge view. Okay. On the right side,
27.
okay. Now I have one other column I've added where you are to put an N, I, or an O. Guess what that's for? Normal, inclined, or oblique. Okay. So then you look at it and you say, I saw face, went to my adjacent view, edge, edge. Which plane is it?
Normal.
It's got to be a normal plane by definition. Let's look at E, just so you see how that works. Let's look at surface E. Let's start in the front view, because that's usually our most descriptive. So surface E, in the front view, what is it? 15. Top view?
4.
Okay, 4. Right side?
29.
29. Okay, normal, inclined, or oblique? Inclined. Why,
Right.
David?
Because on 2 of the views you have not lines, and on 1 of these you have lines.
Okay, good. So I have edge
For sure, you say.
right here. I have shape. This could still be normal or inclined. Oblique's out now.
Yeah.
Oblique's gone. Because I have to see a shape in all views for obliques, right?
Yeah.
So I've now narrowed it down to 2. I go to the third one. If I don't see an edge, I see a face here. Okay, that's got to be inclined. And the other thing I know is that these 2 surfaces right here that are displayed, they're not true size and shape. They're foreshortened. So this would be an inclined plane. Okay, you see how to do that?
Yeah.
Good. And please, feel free. You got 20 minutes, you're sick of doing what you're doing on a drawing, you need a break, jump to the back of chapter 5 and do a couple of those visualization techniques. Okay? They're kind of fun to do. And they'll also get you prepped for what's coming up. All right, let's take a break. I want to come back together for a short little discussion on drawings. And then we'll be done for the day. Are we doing a meeting this morning?
Yeah, we are.
Okay. All right. So let's take a 5-10 minute break and we'll come back when everybody's ready.